Let's go over some example problems to solidify our understanding of aqueous solutions and precipitate reactions. The first problem says classify each of the following substances as a strong electrolyte or non-electrolyte. The first case is methanol with the following molecular formula. We can see that this molecule is made out of carbon, hydrogen, and oxygen, which is representative of an organic molecule. So this must be a non-electrolyte. So when this organic molecule is mixed with water, it will be homogeneous, but it will not conduct electricity because there is no ion dissociation. For B, we have barium chloride, and this is a metal with a non-metal, so this is an ionic compound that will decompose into barium 2 plus and chlorine minus. And let's put aqueous because this is in water. So looking at the table, we can confirm that this will decompose into atoms by seeing the chlorides. So the chlorides here has some exceptions, but barium chloride is not one of them. So we can make sure that this is a soluble compound. So because it's a soluble compound, this will be a strong electrolyte. Finally, we have potassium fluoride, and this should decompose into potassium ion and fluorine. So when we look at the solubility rules, compounds of group 1 elements are soluble. So potassium is a group 1 element, so this compound of potassium fluoride must be soluble. So this is a strong electrolyte because it decomposes into ions that are able to conduct electricity. The next example problem says the following. Use information in table I1 to classify each of the following ionic compounds as soluble or insoluble in water. The first case is potassium phosphate, which has the following formula. We can see that from here, potassium is a group 1 element, so by the rule of soluble compounds, compounds of group 1 elements are soluble. We can also check the rule for phosphate ions. So for phosphates, they are insoluble except for those of group 1 elements and those that have the ammonium ion. So because it has a group 1 element, this is a soluble ionic compound, which should dissociate into potassium ion and phosphate ion. For B, we have lead chloride, and for this case we have a chloride ion, so we look at the rules for chlorides. So it says that chlorides, bromides, and iodides, except for those of silver, mercury, and lead, are soluble. So this is within an exception because lead is an exception of chlorides. And it has a star note here that lead chloride is slightly soluble. So let's be accurate. So this is slightly soluble. For C, we have cadmium sulfide. So we check the sulfide rule, and it says that sulfides are insoluble compounds except for those of group 1 and 2. elements and those that contain the ammonium ion. So cadmium is not a group 1 element or a group 2 element, so this is an insoluble compound. And finally, we have barium sulfate. So we check the sulfate rules of solubility. So for sulfates, which are right here, it says that sulfates are soluble except for those of calcium, strontium, barium, lead, mercury, and silver. So in this case, barium is one of the exceptions, so it's an insoluble compound. In the next problem, we mix two ionic compounds and we have to write for each reaction the chemical equations describing the formation of the precipitate. That is the overall equation, the complete ionic equation, and the net ionic equation. And we have to also identify the spectator ions. So we start with these two compounds and we write the overall equation. So we have this ammonium chromate in aqueous solution and is added to barium chloride, also in aqueous solution. And to write the products, let's first write on the next line what will be the complete ionic equation by writing the individual ions. So we have the ammonium ion with a plus sign in aqueous solution, the chromate ion with a 2 minus in aqueous solution, the barium 2 plus in aqueous solution, and the chloride ion in aqueous solution. So we cross the cation with the anion of the different compounds. So we get for the first one ammonium with chloride, and they have a +1 and a -1 charge. So when we cross the charges, we get a 1-to-1 ratio. And then the second one is barium chromate. So barium has a 2+ charge and chromate a 2-, so when they cross, they cancel each other out, and we get a 1-to-1 ratio. So let's check the solubility. So this is a chloride. So the rule for chlorides is that they are soluble except for those with silver, mercury, or lead. So this is not one exception, so this must be aqueous or soluble. Barium chromate, the rule for chromates is that they are insoluble for all cases. So this is a solid, the precipitate. So then we have to make sure that this equation is balanced. So we see here that there is a factor of 2, a subscript of 2 in the ammonium ion, and there is also a subscript of 2 for the chloride. So we must multiply this times 2 to make sure that everything is balanced. We have the same number of each element on the right hand side as in the left hand side. So the next step is to write the ions on the right hand side, and we have the ions for ammonium, and we have 2 of them from the balance equation, and we have 2 chloride ions as well. And finally we write the solid. So I'm writing on the next line because I'm running out of space, like this, and this is not divided into ions because it's the precipitate. Then we cancel on the left and right hand side the ions that we have similar. So these also must be balanced. There is a 2 here and there is a 2 here in the chloride. So we cancel the two ammonia ions, the two chloride ions, and we are left with the chromate ions plus the barium 2 plus ions, both in aqueous solution, forming the precipitate barium chromate, a solid. And this last line is our net ionic equation, whereas the second line is the complete ionic equation. And the spectator ions are the ammonium ion and the chloride ion. In the next question, we mix copper sulfate with sodium sulfide. So first we write the overall equation. So we have copper sulfate in aqueous solution being mixed with sodium sulfide in aqueous solution. To get the products, we first look at the ions in the next line. So this copper must be a 2 plus aqueous solution because sulfate is a 2 minus. So because they have a 1-to-1 ratio, when the charges cross, we have 2 for the subscript of copper and 2 for the sulfate subscript, but they get simplified to 1. So they get a 1-to-1 ratio. This is also aqueous. And then for the sodium, sodium is in group 1, so it's a +1 aqueous, and then sulfide is a -2 aqueous. Then we put the cation with the anion of the other molecule, and same for the other one. So the first product that we get is copper sulfide, and they have also a 1-to-1 ratio because they have a 2 plus and a 2 minus that cross and get simplified. And the other product is sodium 2 sulfate because the -2 gets crossed and passed to the sodium, and then the +1 of the sodium is crossed and it gives a 1 subscript to sulfate. And this is aqueous, as we will see here in the table. Here for sulfates, sulfates are soluble except for calcium, strontium, barium, lead, mercury, and silver. But sodium is from group 1, so it's not an exception. So this is soluble or aqueous. For the case of copper sulfide, sulfides are insoluble except for those from group 1 or 2, or the ones that contain the ammonium ion. So copper is not an exception, so this is insoluble or solid. Then we have to make sure that this overall equation is balanced. So we have 1 copper, 1 sulfate, and 1 sulfate, 2 sodiums, 2 sodiums, 1 sulfur, and 1 sulfur. So this is balanced. Then we need to write the ions on the right hand side. So the copper sulfide is a solid, so we just write it as a molecule, and then sodium and sulfate ion are in aqueous solution. Then we cross the ions on the left and the right hand side. So the ones that we cross are sodium, sodium, and then the sulfate ions on both sides. And the overall equation that we get is copper 2 plus aqueous plus sulfur 2 minus aqueous going to copper sulfide solid. and this is the precipitation reaction and the net ionic equation. And the spectators that we get are sodium and sulfate ions.